Good morning, everyone. I think we have waited enough. Let's start with our lesson. So what we have talked before, we talked about net ionic equation, dissociation. We said when an ionic compound is dissolved in water, if it's soluble, it dissociates into ions. Dissociation was separation of ions in ionic compounds. When we talked about their dissociation, we had 6 rules in order to figure out which if they are soluble or not. After that, we looked at the combination of 2 solutions. For example, when we mix two solutions, will they precipitate or not? And depending on the rules that we have studied before, if the attraction between the 2 ions are greater than the attraction with the water, then the water cannot separate them and a precipitate is formed. And we talked about net ionic equation. After we mix those 2 things, if a precipitate is formed, it means that 2 ions are connected to each other or attracted to each other, and then precipitate is formed. We solved 2 questions. In question 2, there wasn't any net ionic equation. Why? Because none of them formed any precipitate. That's why if there is no precipitate, all of the compounds are soluble, then they are called as, or we'll say that they don't have any net ionic equation. But for example, if we solve question 1, or let's solve question 3 actually. Question 1, I'm gonna post 1 or 3. Yeah, 1. Because I'm going to post question 3 solution afterwards. Question 1, will a precipitate form if solutions of potassium sulfate? What is potassium sulfate? So potassium is positive 1, sulfate is 2 negative. See, the 2 is here, 1 is there, then it becomes A2SO4. Then barium nitrate, Ba is 2 plus, NO3 is minus 1. The 2 of the barium gets here, and the 1 is in front of the barium. Then it is Ba NO3 by 2. AQ. Then, what is going to happen? When we switch the cation with another cation, or the anion with the anion, we will get KNO3 with BaSO4, but we don't know if they are soluble or not. If we balance it, we get 2KNO3. For the KNO3, we'll say since there is K and NO3, both of them are soluble at any cost, at any compound, then this is of course aqueous. But what about barium sulfate? Barium sulfate contains sulfate ion. We don't have any rule for barium, but for sulfate ion is rule number 4. It is generally soluble, except with what? Except with barium, strontium, calcium, lead, and mercury. So it's with barium. So since it's with barium, we have to say it is solid. It is solid. Now, let's write the overall ionic equation. The overall ionic equation is like this. If the compound is aqueous, then we'll say it has become an ion. Then it's 2K, like this, SO4, barium, 2NO3, again 2K, 2NO3 with, but since this is solid, then barium sulfate will remain the same. And K and NO3 are cancelled. So K and NO3 are spectator ions. We call this one overall ionic equation. Then when potassium and nitrate are like cancelled or removed because they haven't reacted with anything, they are just spectator ions. So the reaction was between SO4 and barium, where they change from aqueous to a solid, barium sulfate. They become solid. So we call this net ionic equation. Net ionic equation. All right. So this was net ionic equation. This is another example. Just a reminder for you so that you can remember what you have studied before. Now, let's continue. If you have written this, we will continue.
والله مساكن يقدر خلص سمان بس يا زلمه
بس عاوز أسمع.
دوما نسيبه
بله.
دوما كردو بيشتل او روجا كردما
پێشتر نووسیتان خۆتان؟
دوما كردوها بس يكم ننسي نازم كردو معنا بس بارس ميكي
نه یەکەممان نەکردبوو، یەکەم ئێستا کردم.
يكم معنا كردو
بەس دووەمان کردووی لەگەڵ چوارەمە.
دوما شوارع ما كردو
ئەگەر نووسیتانە بە بڕێن.
انا بارس ميكي بقرن بوي انا تاخيرنا من داينس
زۆر
اي دسوشتا
کەستر هێنێ نووسی بە کوڕینە؟ باش. کاتە بە بچینە سەر مۆزوعی دواتر. ئێمە ئەمە باسی چیمان کرد؟ باسی net ionic equationمان کرد. جاگە بیرتان بێ we talked about dissociation which was number 1. Now number 2 is ionization. Number 2 is ionization. Dissociation was for ionic compounds. Don't forget that. What about ionization? Some molecular compounds can also form ions. So not all, some molecular compounds can form ions in the solution. So the other one was for ionic compound. That was clear. They just separated, and that's it. But now we talk about molecular compounds where they usually are polars. Not all of them. Not all the polars are ionized or form ions, but some of them. If ions are formed from solute molecules, it says molecules, by the action of the solvent. By the action of the solvent, it means that the solvent reacts. And in here, these molecular compounds are not ionic compounds. It means that they actually, in the original, they don't, or they are not formed from ions. They don't have ions in themselves. Ema bu elleri alın by the action of the solvent. Çünkü basi molecular compound, molecular compound, خود ion itianiye. Molecular compounds don't have any ions. But some molecular compounds, when they dissolve in, for let's say, in water, by the action of the water, when they react with them, they form ions. And if you remember, and go look at dissociation in the first page, as you can see, dissociation, see, I have highlighted this part for you. We said it is separation. But if we go back to ionization again, now if we study ionization here, ionization doesn't say separated, form. So it's formation here. In that place, it was just separation because they they already had ions. But in here, there isn't ion at first, but they will form. So when a molecular compound dissolves and ionizes, dissolves, so it has to dissolve, then ionize. These are two different things. First, they have to dissolve, then they can ionize. But some things they dissolve and they never ionize. In a polar solvents, ions are formed where none exist in the undissolved compound. This is what I mean. This is the thing that says that I explained it before, where I said there wasn't any ion before it was dissolved. So that's what it means. Ions are formed where none exist in the undissolved compound. So there wasn't any ions when the compound was formed, but the ions are formed when they dissolve in water, when they ionize in the solvent by the action of the solvent. And like all ions in aqueous solution, just like any ions, if they are in water, aqueous solution, if they are in water, they are called what? Hydrated. Just like any compound. If you see any ion that is surrounded by water, any ion that is surrounded by water, we call it that we call the ion hydrated. We call the ion hydrated. All right. And when these compounds undergo hydration, energy is released as heat. شيل energy release evet. Energy ile شوي heat release evet. Of the ions, during the hydration of the ions, just شيء استفادة شيء من الجرمية. Energy release استفادة شيء. What is the importance of this energy that is released? Provides energy needed to break the covalent bonds. So it will break the bonds and make them ions. All right, and like make more ions. They are needed in order to break the other bonds of the other molecules. Because if you remember, we said for breaking bonds, we need energy. Where does this get the energy? From the dissolution. When it dissolves, it releases some energy, and that energy is used also. Some of that energy is used to break the covalent bond. We are still not done with ionization. Let's see what ionization depends on. Ionization depends on what? Ionization depends on two things. Strength of the bond within the molecule of the solute. Is the bond strong or not? If the bond is strong, maybe it cannot be broken. Maybe it won't break, and then they cannot become ions. كواتا جرحات molecular compound ديك بوندكي بقوت بو أو كاتا بوندكي نشكت كنشكة أو كاتا نابي بقانا. And what else? Because if the bond is very strong, it will not become an ion. What else do we have? Strength of attraction between the solute and the solvent molecules. How strong the solvent can attract the solute? Can it separate the solute or not? Does it have a good attraction or not? All right. So in order for the bond strength, I have written this. Bond strength is inversely proportional with polarity. Bond strength is inversely proportional and inversely proportional with ionization. As we said before, if we have a high bond strength, ionization decreases. And if we have a low bond strength, ionization increases. Bond strength حتى كم تربي باشتري ionize باشتري كا بو لبري بوندا كان ياسن ترشكه. جاتشيش ما بياله the lower bond strength, the higher the polarity. You don't recognize anything like this. روش تاننا ناسيتو. كلنا. شو نازني مثلا تشتك بوندكي بهذا تشتك بوندكي ضعيفة. You don't know which one has a strong bond or weak bond. We will tell you which one has it, which one doesn't have it. You have to memorize some examples that I'm going to give it to you, or that is written in the book. You will just learn about the compounds. But there is not a general rule that you know which one has a high bond strength or not. Vale.
May I ask a question?
Yeah, please.
Does ionic bonds considered to be ionized?
No. Ionic bonds, which are ionic compounds, will directly say dissociate, not ionization. So that's what is the difference. That's what we are trying to distinguish. For ionic compounds, we have to say dissociation. For molecular compounds, for covalent bonds, only we'll say ionization. Rasha? All right?
عفوا.
Good.
Also بسالك من عزم نبي.
So if something has a high polarity, it means that this thing can ionize very good. But in order to have a high polarity, the bond strength must be low. There is another name for bond strength. We can also call it bond energy. Why bond energy? Because of the energy needed to break the bond. If it needs a lot of energy to break the bond, it means that the bond is very strong and it cannot easily be broken. That's why that compound has a very low polarity. Then ionization is not easy. It will not ionize a lot. Sometimes there's ionization, but it's very small. Sometimes there is ionization, but it's very high, which we are going to talk about after this. All right. This is the explanation. If the strength of the bond within the solid molecule is weaker, if it's weaker than the attractive forces of the solvent molecule, so if it's weaker than the solvent molecule, which the solvent can separate the ions, then covalent bond of the solute breaks, and the molecule is separated into ions. Then the molecule becomes ion, like HCl. So HCl is very polar. It's highly polar, and it dissolves very well in H2O. So its solution is favorable. What does favorable mean? High tendency. It wants to be dissolved. That's what it means, favorable. Its solution is favorable. Then it's high tendency to dissolve. It really wants to dissolve. But when it dissolves, it will, as we said before, it will release energy. So the dissolution of HCl is favorable. It really wants it. It's easy to do. It can easily dissolve in water. It can easily dissolve in water. It can easily be dissolved, and it's exothermic. كواتا هم حزكها بتويتو وانرجي ريليزاتها. Then when a molecular compound dissolves, molecular compounds, they don't have ions. Then which one becomes the positive? If they are not ions by themselves, which one becomes the positive and which one becomes the negative? According to this note, the more electronegative element will become the more electronegative element becomes the anion, becomes the negative. What is the more electronegative? The one on the right. For example, we have like if you remember from 11th grade in chapter 1, always between two elements, which one is on the right? The one with the higher electronegativity, like HCl, like HF, Cl and F, for example, are more electronegative than H. If you see two elements like that in molecular compounds between two nonmetals, because if you remember for covalent compounds, we said it's formed from nonmetal and nonmetal. And between those two nonmetals, which one is written on the right, which one is written on the left? We'll say the one with the more electronegativity will be written on the right. لأن الراس تونس. أو electronegativity بالسترا ولا الراس تونس. And when a more electronegative element they undergo ionization in a compound, they become the anion. They become the negative one. So, for example, HCl. When they have undergone ionization, the Cl, which is more electronegative, which is, well, how do you know it's more electronegative? It's written on the right. Becomes the negative. هذا anion. فواتلم ولا هاد كاتك compound يك ما هبو كبوبا ion جابو بوبا ion أو إلا الراست منو electronegativity تو بيست بين يبو حل كردين بسيار أكثر لي أو إلا الراست أو إلا negative أي بوشي أمانة دير عشان حنسيو أجر بسيار هاتو تي كمان والله نابع والله ما يكوني ولا أو إلا الراست والله مع النيجاتيف the more electronegative element will become the negative. Because there are sometimes a question, it will tell you which one will become the negative during ionization. You will say the one with the higher electronegativity or the one that is more electronegative. All right. So again, if something has a low bond strength or low bond energy, the bonds can be easily broken. Then they will have a high polarity. They will ionize very well. They will ionize very well. But something like HCl, when they separate into H and Cl, they never, or the H will never stay alone. The H will never stay alone. What do we call this H? H positive, a proton. Why do we call it a proton? The only thing that you can call a proton is this H. Nothing else you can call it proton. Only H. Why? H as an atom, not as an ion. So this is H as an atom. Has one proton and one electron. That's an atom. If it loses an electron, like this, loses an electron, they become like this. One proton and nothing surrounding. Because all of you know, when we say an atom is neutral. What is the neutral? It means that the number of the protons and the number of electrons outside around the shell are equal. If you have 10 protons, you have 10 electrons. 20 protons, 20 electrons. And when they become ions, it means that they will lose electron or gain electron. If they lose electron, they become positive. If they gain electron is negative. That's why they become negatively charged. Since hydrogen here loses electron here, it becomes a H positive. What is left? Only a proton is left. This is true only for hydrogen. There isn't any other element with one proton only hydrogen. And when the electron is lost inside that atom, when it becomes ion, only the proton is left, nothing else. There isn't any electron, there isn't even neutrons. That's why this hydrogen ion, we can also call it proton, because it's only one proton. But for example, if something like lithium, the next thing that loses electron is lithium, which has 3 protons. الشكل ده أو كبتوان إلكترون دونيتكا lithium is 3 proton. This is 2 electrons here, 3 electrons, and that's it. When it loses this electron, it still has three protons and two electrons. So we cannot call lithium a proton. Lithium is just an ion, a positive ion. But hydrogen, when it becomes a positive ion, we can call it a proton. يعني بس بيقبل البروتون. مش كبس تنهاك بروتون يعني الكترون ما شبه. والرشتو بلاشية. The electron has been lost to Cl. Cl has taken the electron. Now, we learned that the hydrogen is proton. And this hydrogen attracts other molecules. It can react very strongly with other molecules and other ions. So strongly that it doesn't normally exist alone. So that's why hydrogen ion or proton never exist alone. We never have hydrogen alone. There always must be with something, which in this case will react with H2O. So from now on, instead of just separating the HCl like this, the one that we studied before, to H and Cl, we'll say that the H2O will react with the HCl. And that was actually one of the requirements of ionization. What was ionization? We said the formation of ion by the action of the solvent. This is the action of the solvent. As you can see, the H2O has reacted. The H2O is one of the reactants. فاتها إما برونو سر جري كم مال chapter اشتكى متم خد بشش اشتكى بينه وتم أجربي برونو سر بقولن للا برا سنة كذا للا برا سينويا لا paragraph هي كما آخر دير وتمانا ionic compounds doesn't need action of water ionic compound بيسيب action الأوكانية حتى هاكو solvent يقاركو بقولن يارد دير بكاري يعني بلا molecular compound كان precipitate أبي أوكر reaction كلا كذا الساليرة شيء كان action أوكر لقلا reaction كان حتى كشين سبناسي ionization ionized action of the solvent يعني شيء يعني reaction لقلا كان بالفعل لو صار reaction لقلا شيء لقلا إتشكيه. This part is actually this reaction is actually composed of two parts like this. HCl at first is separated in the H2O. It becomes Cl and H. The Cl is also left. That's it. It's remained like this. But this H cannot stay alone. It will react with the H2O, the solvent, which is the H2O, and become this H with the H2O becomes H3O. All right, becomes H3O. So why? Because H2O, two hydrogen with one hydrogen more becomes H3 hydrogen, and the oxygen is left. And this charge is neutral. This charge is positive, so the total is positive, and we still have Cl. And when we write all this equation together, this is how we are going to write it. The HCl has reacted with the H2O. At first, it's this dissolved, this separated, and the H, this H, where it's separated, will react with the H2O and becomes H3O and Cl. الرياكتنت كتير ما مذاكر على لعبة ما ذاكر كات أم H2O توين يكسب تنجم بنوسين أم دوان دوبا شيء Cl و H كبر تحتنا أنا نوسين يكسبلن بو H3O Cl. Rasha. And what do we call this H3O that is formed? We call it hydronium. H قد بتحتنا كبروتون بتحتنا نابت. إقل لك آواجك بقريبة بس شيء hydronium. Hydronium ion ياخذ hydrated proton. ياخذ hydrated proton.
مسجان
كيف بتسهل يا بابا؟
ما بصا
بلا
عزلنا بيتواني لخالي د H plus انا كوا H plus كوا دوباري كيتو عزلنا به
باش أمي رياكشن كخم نسيمة
نحن خدنا حر خالك دوباري كيتو منهم
كامجان
هلا H plus أكو دوباري كيدوها the H plus ion
أو باشا كإيش خلاص عن attracts
اللي
other
بخار دوباري
molecules
كيدو يكجاري سباس تكا
ما بس أوي كون أرنوتي دوم يعني لوانيا
بلا نوتي دومي
على the H ion proton attracts other molecules على H شي هي attract لقاش تكين attract لقا مثلا ليريا سيري أماكا H attract شي كردو لقاك شيء كي كردوا لقال H2O كي أولا بقوتي الرأي الشاوة so strongly زور بهزي يعني لقاك شي كردوا كشي درسكات covalent bond كي لقال درسكات يعني شتێک دروستەکات کە پێشتر چی بووە کە پێشتر نەبووە يعني یان ببرن نەک پێشتر نەبووە يعني بە شێوەیەک ڕاکێشێ کە يعني دایمەن هەوڵ ئایا لەگەڵ شتێکا بێت بەتەنیا نەمێنێت بۆیە لە does not normally exist ئەوە بۆ لەبەری دایمەن لەگەڵ مۆلیکولەکان لەگەڵ ئایۆنێکە باش ئەتراکشنە ئەوە تا مەسەلەن لێرەیە H بە تاقی تەنیا نەماوەتەوە H چی کردووە لەگەڵ H2O-کایەکی گرتووە بۆ بە H3 باشە ئێستا مەسەلەن کە HCl-ەکە جیاوەتەوە بۆ بە Cl و H H-ەکەش بە تاقی تەنیا نامێنێتەوە ئەتراکتی چیەکە H2O-کە لەگەڵ H2O ڕێکشنەکە یا بێ بەچێ بە H3O ئێمە جو H3O ناوێنن هایدرۆنیۆن لەمۆلا ئیتر ئێمە کە ئەینووسین ئاوانووسین HCl لەگەڵ H2O ڕێکشنی کردووە ئەوێ بە H3O Cl نابێ بڵین بە H و Cl چکەیتر H2O-کەش بەشێکەوە H2O-کەش ڕێکشنی کرد باشە خۆ اینجا مثلا ڕەنگە ژماری پرۆتۆنەکان و چۆنێتی دەورانی ئاوەکە تۆزە بگۆڕێ بۆیە جەنرال فۆرمولەیەکیان داناوە کە H2n+1ON ئەمە یعنی چی ئەمڕۆجان ئەم فۆرمولە یعنی چی ئەو فۆرمولەیە ئەگەر جارێک تر بینووسمەوە لێرە يعني n هەر چەندێک بێت n هەر چەندێک بوو تۆرە لێرە دەبنێ H ئەو ژمارە دەرەچێت بۆ منە ئەگەر n سێ بێ ئەگەر n سێ بێ کەواتە ئەما کاتە چەندێک 2 کەڕەتی سێ زائیدەن یەک ئەکاتە چەند 6 ئەمە کەواتە ئەبێ هایدرۆجین چەندێک بێ بێ هایدرۆجین سێ بێ ئەمە فۆرمولەی هایدرێتد پرۆتۆنە بۆ نمونە بابێنە سەر پرسیاری سێم پێشەوەی پرسیاری یەکەم دۆم پرسیارەکە ئەم پرسیارە طبعا H3O هایدرێتد پرۆتۆنە بەڵێ ئەوە H3O هایدرێتد پرۆتۆنە ئەوە ئاسان ئیر ڕوڵەکەشکەن ئەم ڕوڵە بابێن سەر حەزەکە هایدرێتد پرۆتۆنەکەش H3O-کەش با دیاری بکەین سێریکەن مەسەلەن ئەگەڕن H ئۆکسیجینەکە چەندێکە H3O ئۆکسیجینەکە یەکە فقط ئەگەر ئەمە یەک بوو ئەیە ما کاتە چەند 2 کەڕەتی یەک زائیدی یەک کەواتە کردیە چەند کردیە سێ کەواتە ئەبێ سێ بێت هایدرۆجینەکە سێ بەڵێ سێ کەواتە ڕاست بابێنە سەر B ئێنەکە چەندێکە ئۆکسیجینەکە لێرەیە سێ کەواتە باجارێک تر ئەمیش بنووسینەوە بۆ B H ئەمە سێ هایدرۆجینەکە بێ کاتە چەند 2 کەڕەتی سێ زائیدەن یەک کەواتە ئەبێ بکاتە 2 کەڕە سێ 6 و زائیدەن یەک ئەکاتە حەوت کەواتە ئەمیش ڕاستە حەوتە کەواتە ڕاست بێنە سەر C وتویتی ئۆکسیجینەکە دووە ئەگەر ئۆکسیجین دوو بێت کەواتە ئەمە چەندەکات 2 کەڕە 2 زائیدەن یەک کەواتە بێ بکاتە چەند ئەبێ بکاتە 5 ئەو چەندی نووسیوە 4 نووسیوە کەواتە C is not correct. Why? Because the hydrogen number must be this formula. What would be the number of the oxygen? It's 2. Again, like this. Hydrogen, oxygen. We can see the hydrogen is 2. Then what would be the number of the hydrogen? It must be just like the rule 2 times 2 plus 1. And it must be 5. But it's written 4, so this is not true. That's why the answer is C. Let's look at D as well. D is HO4. What if the oxygen is 4? What if the oxygen is 4? Then hydrogen must be 2 times 4 plus 1. Then the total is 9. 2 times 4 is 8 plus 1, 9. Is it correct? Yes, it is also correct. Our hydrated proton. That's how you recognize hydrated proton. Now, this question is very good in order to summarize the things that we have learned. First question. Which of the following is not true about dissociation and ionization? Molecular compounds ionize. True. Anionic compounds dissociate. Also true. So A, no problem. See, ionic compounds. In here, everyone, you have to know what is an ionic compound. How do you recognize ionic compound? From the table. But for molecular compounds, which they ionize, don't worry about it. We'll gradually learn compound by compound, especially in chapter 3. Let's look at B. Ionization of in ionization, water acts. True. Yes, in ionization, there is an action of the water, action of the solvent. True. But in dissociation, not. Yes. True. Not a problem. When HCl ionizes, ionize, releases H and Cl. No. After ionization, what will be released entirely? After, they will have H3O and Cl. So this one is true, this one is not. Yes, we know in one of the steps there is H and Cl, but the most correct answer in order to form, in order to look at, is the actually H3O and Cl. That's why the answer is, the answer is C. The answer is C. Yes.
But inside of HCl, we don't have H3O. In HCl becomes H plus and Cl if we write in
yes, but
overall ionic equation.
Oh, no. That's not over. Say, if we look at it, it says ionize, and we concluded that, we explained that it is clear that H will never stay alone. So whenever it says HCl ionizes, it means that as a whole thing, after everything is ionized, what would be left? Instead of saying H and Cl, we have to say H3O and Cl, because H will never stay alone. All right? Yes, you are right.
But I don't understand this. I don't understand the part that H3O doesn't come from the HCl. It comes from H2O. So HCl doesn't have H2O part.
Here, Moaz, the problem here is the ionize, the word ionize. When it says ionize, if you look at the other 2 points, in ionization, what happens? The water reacts. So when it says ionize, it means that the H2O has already reacted with them. Do you understand now? It doesn't say just separate. Okay. If it just says separate, yes, you are right. C, when it separates, becomes H and Cl. But HCl doesn't just separate; it will ionize. What does ionization mean? Ionization means that they will form ions and react with the solvent. So when it says ionize, it means that they have reacted with the solvent. That's why it must be H3O. All right.
Sir, can I ask a question?
Yes.
Sir, always when ionization happens, always the H2O should react with some compounds?
Yes, always.
Okay.
And most of the time that we study, actually all the times that we study here, it's always H2O. Question? Any more questions? We'll solve this question. I'll give you 10 minutes. I know that I have gone like a couple of minutes over the your break, but I want to solve this question. Then I will give you the exact 10 minutes. Don't worry about that. Okay. The next question: the hydronium ion contains what? So hydronium ion, if you look at the explanation of hydronium ion, it says it's only forming covalent bonds. Because we are talking about molecular compounds. We are not talking about ionic compounds. There isn't any metal. There isn't anything that makes ionic compounds. So from that point, you can directly cancel C and D because there isn't any ionic compounds in H3O, hydronium ion. What about A and B? So this is what is formed for hydronium. This is hydronium and oxygen with 3 hydrogens plus with 3 hydrogens. So if you can see, the oxygen has formed with the same 3 hydrogens. That's why the answer is 3 equivalent covalent bonds. So the bonds are equivalent, the same bonds. B says they are unequal. They are unequal strength. No, that's not correct. You can say all of them are equal, means that the 3 equivalent covalent bonds. Same strength. Please be careful. Not all ionic molecular compounds ionize. Molecular compounds, I have prepared a diagram, a graph for you, so that it's easier for you to understand everything. But for now, and not all molecular compounds ionize. Let's look at strong and weak electrolyte. In chapter 1, we only studied if something is electrolyte or not. Now we talk about the electrolytes, but also divided into strong and weak. What does it mean, strong and weak electrolytes? Some of them conduct electricity very well, very strongly. That is a strong electrolyte. Some of them conduct electricity very weakly or very poorly. We call that weak electrolytes. It conducts electricity. It is weak. It's not a lot. Electrolytes are substances that yield ions. This is a revision from chapter 1, and conduct an electric current. And the strength, now we are talking about the strength, with which substances conduct an electric current is related to the ability to form ions. So how much ion is formed? If it can form a lot of ions, then it can conduct electricity very well. If it can form only a very small amount of ions, then it cannot conduct electricity very strongly. That's why strong and weak electrolyte depend on what? The degree of ionization or dissociation. How much the compound will ionize? Will it ionize a lot or not? If you remember from the top here point, we said ionization sometimes is high, sometimes it's low, according to the bond strength, or according to polarity. From here, we will gradually learn about those compounds. We'll gradually memorize those compounds. Which one can ionize very strong, which one is not. So strong electrolytes, any compound whose dilute aqueous solutions conduct electricity very well is called strong electrolyte. So if a solution conducts electricity very strongly, it's a strong electrolyte. Why? This is due to the presence of all or almost all of the dissolved compound in the form of ions. It means that every molecule, everything that is dissolved, all of them, what will happen to them? When they dissolve, they become ions. إذا بس يقصد شيء بو عليه بوي سترونغ لبروي أو كأتويتوا هامي ببعين هامي أبي بعين بوي حساب سترونغ بوكي. And we categorize into 2 parts the strong electrolytes. We have 2 types of compounds which are strong electrolytes. The first one, these 3, which you have to memorize for now, are molecular compounds. And these molecular compounds, when they dissolve in water, they ionize very strongly. And we call it ionized completely. Please write this down. Ionized completely. But شيخن بطواتي ionized ذكر بطواتي أبن بأيون. When normally these 3 HCl HBr are generally gases. They are formed as gases at first. So they are not ions. They are not solutions. Katana ion and solution gas. But then when we would put them in water and we make them dissolve, they can ionize and become H3OCl. And they ionize completely. What does that mean? It means that all of the HCl, see, the presence of all of them of dissolved compound in the form of ion. They all become what? They all become ions. هادشي HCl جميع بأيون. يعني HCl خوي نامنته بموليكولي. يعني ببكتيريو بمثانو بيكون نامنته. بأتاشي بيكون نامنته. HCl هم بأيون. So none of the HCl will remain in this solution. All of the HCl will become H3OCl. HCl will be no longer available inside the solution. Same thing for HBr, same thing for HI. That's what we call 100% ionization or complete ionization. Her كاتب ionize completely كرت يعني بطواتي reaction كدو لقى عوضها هو بأي. Alright. So this is for molecular compounds. And all soluble ionic compounds, are strong electrolytes. But these ones, they don't ionize, they dissociate. No matter the amount of the solute or the ionic compounds, when they dissociate, they are either soluble or insoluble. If they are soluble, complete dissociation. لا ionic compound ده يا ناتوتو يا ناتوتو. Because like molecular one. So the difference between ionic and moleculars, like sugar, for example, they can dissolve, but they don't ionize. They don't become ions. They dissolve. But ionic compounds, they will either dissolve or not. If they dissolve, they dissociate. That's it. We don't have anything else. All right. If ionic compounds dissociate, they are directly strong electrolytes. They just dissociate, they are directly electrolytes, strong electrolytes. Like KNO3. KNO3, in here you don't have to memorize these compounds. For ionic compounds, you have to recognize them from the two tables of last year, from the cation and anion. Metallic and metallica, such as NaCl also. So it changes from NaCl. When we put it into H2O, they dissociate to become Na and Cl. Na is Aq, Cl is also Aq. So they are directly strong electrolytes. Directly. As long as they dissolve, they are strong electrolytes. كواتا موضوع يعني compound بس أوي كبتويتو بس بتويتو أكثر strong. بس بتويتو strong. بس بموليكولار واني موليكولار بقى ionizing كتواويش بكن. باشا وكردوما بالتيبل كله جاية نك بالتيبل ما بين بالجرافيك بتجاني همش تكان شيب بو. What about weak electrolytes? What is a weak electrolyte? Any compound whose dilute aqueous solution, if it's in aqueous solution, if it's in water, conduct electricity poorly. Why? Why do they conduct it? Because of the presence. All of it becomes ion. But in here, yes, due to the presence of small amount of the dissolved compound, only a small amount has become what? In the form of ions. Precipitation compound the 12 ion. Precipitation هذا molecule منته. Some molecular compounds form aqueous solutions that contain only dissolved ions. That contain ions, but not only dissolved ions, but but also most of them dissolve molecules that are not ionized as molecules. من ionized molecule توكان شتيا بلنبون بعين. I'm going to repeat that. Sometimes when molecular compounds form aqueous solution, they can ionize, but ions are not the only thing that is present in the solution. What else is also present? the molecules are also present. So for example, in this part, all of the LCl has become ions. Everything has become ions, but in here, no. Most of them has remained as non-ionized or stay as molecules. So this part is the non-ionized molecules. They are just molecules. This part, they are ionized. So they are ions. If you look at the symbol here, as you can see, the symbol is written like this. It's reversible. أحب شيء نسراوه. Reversible نسراوه. يعني شيء reversible. Since it can go back and forth, not all of them has become ions. Some of them will come back to become molecules again. They will be at equilibrium. If one molecule becomes ion, and that's it, if it reaches equilibrium, there is always a change between them. One molecule becomes ions, and the ions go back to become molecules again. How equilibrium okay? هيك كتشت درويش كتنا دائما شيء دائما لقوا ركاريا. فلام رجكي, but the ratio will remain the same. For example, maybe like for acetic acid, I think it's 2%. 2% become ion. 2% ion, for example, for CH3COH, which is acetic acid. All right, 2% become ions. Around 98% remain as dissolved molecules. So we don't have any problem with the dissolution. They will dissolve. There's not a problem. But when they dissolve, only a small amount of them will become ions. The rest is just molecules. كشكت شيء لده هم يأتوا هيك كشيء توانو مانية. يعني يوم يبغى والله إنها أتوا بلام تنها بريكي أبي بعين بركيتي هذا وكم molecule كيف شون شكل molecule تواه أيش واه هر أواني عشان كاتبون من same thing for HF. HF will ionize, but only a small amount. Let's say maybe 30% will ionize. The rest will remain as molecules. Same thing as molecules. All right. That's what it's called. What do you call these? Ionized partially. But instead of ionized completely, we'll say ionized partially. لبريبل إن الصاصة هم يبوا ion. هم مثلا هم بوا ion ووالياتها أو ببا بابلن بش شيء أبي ion. باشا. I want to repeat ionized partially. Due to this partial ionization, and we don't have a lot of ions, the electrolytes are weak electrolytes. So for weak electrolytes, until here, you will memorize these two compounds, HF and CH3COH. All right, and for this one, you will memorize these three: HCl, HBr, and HI. HCl, HBr, and HI. All right. Until now, you have only memorized these five, but for ionic compounds, you have to recognize it by yourselves. أبي خود بناستو بو ionic compound. أبي خود زانك metal من metal أمشتانا. باشا. All right. For example, like this question. Which of following is true for aqueous solution of HF? كم راستبو HF. It is a strong electrolyte. No, HF is not a strong electrolyte. It's a weak electrolyte. So this is not correct. It doesn't conduct electricity. No, it conducts electricity, but it conducts acid, but is weak. So this is not also correct. It is completely ionized. No, it is partially ionized. If it's partially ionized, then most of the HF, see, most of them dissolve molecules that are not ionized, remain as molecules. So this one says the same thing. Most of the HF remains as non-ionized dissolved molecules in solution. بشويكي تواوا بلام شون non-ionized نابن بعين بلام نابن بعين يعني solution كا كاتبلع مرة راسته يعني بشي كي بعين بس بشي كي زوري هروكم molecule أمانته بوي بيتر بيكالكتور كسر بالسيارة يا باويدا كسر كشي لقلا ما هذا ئێستا کە سەیری گرافەکەی خوارشمان کرد زۆر جوانتر ئەو مەوزوعی سترۆنگ ویکەکەت بۆمان جیابێتەوە کوڕنە پرسیاری دوای ئەوە look at the next question which one is a strong electrolyte answer the question
None of them.
Why?
Because HF is a weak ionizes partially.
Partially, very good. What about A? What about sucrose?
Sucrose doesn't ionize. Doesn't ionize.
Doesn't ionize at all. But AgCl is an ionic compound. What about AgCl?
It doesn't because in the table it says
so it is
except AgCl H2SL2.
So it is what? Insoluble.
Non-soluble.
Yes, it does not dissolve. كواتا كورينا شكر وثمان non-electrolyte. We said sugar, sucrose is non-electrolyte. That was in chapter 1. HF, we have just studied that it is a weak electrolyte. But some students mistaken AgCl for strong electrolyte. Why? Because they say AgCl is an ionic compound. Yes, you are right. AgCl, let me write this one. AgCl is ionic compound, but it is not soluble, so it's insoluble. HF is weak electrolyte. Sucrose is also a non-electrolyte. So whenever we said in order to become a strong electrolyte, it's either those three, or the ionic compound must be soluble. AgCl is not soluble. So the answer is D. The answer is D. So again, this explanation I have explained it before. If attraction of polar solvent molecule is stronger than the covalent bond in the solute, so if the solvent is stronger, it can attract the covalent bond it's stronger than the covalent bond, the bonds will break, and attraction determines whether the molecular compound ionizes or not. So if there's a good attraction and it can break the molecular compound, the covalent bond, then it will ionize. Basha. أوش جوازي بين strong weak. Strong, they ionize completely. They separate into ions completely. Everything will become ions, but weak only partially. Strong electrolyte conducts electricity very well. Weak electrolyte conducts very poorly. So look at this graph, everyone. This graph, it's better to look at it in your notebooks or in your booklets. Let's see if we can rotate it like this. Can we rotate it? I'm not sure. No, I don't think we can rotate it. All right, let's just leave it like that. Everyone. So compound, you remember from the first thing that we said, compounds can become ionic compounds and covalent compounds. Ionic compounds, they're either soluble or insoluble. See, I said something like that. Ionic compounds, they either dissolve or not. If they dissolve, if they are soluble, they directly dissociate completely. and they directly become strong electrolytes. That's it. يكسر شيء بيت ببي قيد وشرط. If ionic compounds are soluble, they dissociate and they become strong electrolytes. Not any more options. But what about covalent compounds? So strong electrolytes, one part of strong electrolyte is here. What about this part? Covalent compounds. We said covalent compounds are either polar or non-polar. We remove the intermediate. Why? In order to understand intermediate polarity, it's better to do like this. If we want to like understand in a more advanced way, instead of saying intermediate, we'll say something else. So covalent compounds normally are, if you remember in the first lesson, so I said the same thing. It's either polar or non-polar. Polars, they either ionize or don't ionize. So if they don't ionize, this is the intermediate polarity. This is the same as intermediate. All right.
حسبنا بيك يكشت.
طلع.
Ionize يعني لغاز وبابو ion وايا.
لا كرم ما اينايز بس يوم نكر وما او نمونانا لغازو هروابون باين اينايز يعني ككتا نو او بباين هو molecular compound green molecular compound
يعني غاز بهر شيء
هر شيء غاز بالليكويد بهر شيء
ايه تمام هم زاني بس غاز
بله عشرني هر غاز به هر شيء به بس molecular compound به اگر بو با ion او ionize کرده So they don't ionize. If they don't ionize, they dissolve in water. هل باش نسي وتم أتويتو كشين توانوينيا بس ionize ناك بقولنا شكله تويتو alcohol تويتو بس ionize ناك بمعنى لنشي electrolyte chapter يك نمبولار كان وهي جو نمبولار كان هر الله ما بولار نمبولار كان هو ionize وشد ناك بلا ما يقدر ionize يكت أبى electrolyte ionize يكت سير كان ionize يكت أبى electrolyte اگر بو electrolyte کاته دو جاش معه يعني تا completely ionization كان partial ionization بون ندرس بعد كان هو strong سيده كان وكو شي تا SMS نمونه ما خلنا دير HCl HBr HF MS يعني ما خلنا اي بو ويك كان شي ما خلنا كعمل شابتر سي هر هم يعني خلانين بس تا است شي ما خلنا بو برن اما HF نبو HI خلطي منجو HI أما عندي HF زائدا TH3COH أدونه من
ما وصلت وين توس شاشة قبري بربلاي شاب ديارني نسينا قال لا يا مو
أوا
بلا أوا وكدو إيه برو خوارو
أوا باشترا
بلا بس
ويتوزر رأي كيشتو بويا كيشكل واحد كاتسات شيبو وتمان أجر هاتو covalent compound كان كم بدو بشو polar ونم polar كان أجر بهات ionize كا أو بإلكترولايت ionize نكا أو ببنان إلكترولايت بس لا أوهر تتو ionize كده أو بإلكترولايت كا شكله بدو بشيترو يعني تبى طاطي يعني تبى partial ماشي كورينا جا مثلا با عین کمپاوند کان نشود من دامن که توی و یکسر ابی به دیسوسییت کاتو ابی به استرونگ الکترود ها چون کلمات کان بکارنا سه که مثلا با پولار کان که مولکولار کمپاوند آینایز بکارنا بالام لولا با عین کمپاوند دیسوسییت بکارنا
سجان
بله
پێویستەکە نمونونەکانی ئەوە ئەگزامپڵەکانی سترۆنگ ئەلکترۆلایت دەستەکانەوەی ئەیەکە هەمووی لە بەرکەین
والله لا بأسيانة لإستاء لبركان شكا دعاية يارمتيتان خوار بدعاية بيزانة
عین دوایە لە بەریکەین ئێستا لە بەریکەین باشتر
لإستاء لبركان باشتر شكا دا شابتري سيا كاشين شابتري سيا هر بينك بلا من مثلا بيش شابتري سيا لبري كويزا كم رنگ بيان مو
يعني پێویستەکە بزانین HCl و H2O تێکەڵی هەیە ئەوێ بچیان بەس HCl و HBr و HR
بزان ئەبێ بەچی بەس ریاکشنەکە زۆر بە هەموو جای من ریاکشنە نایەم بڵم ریاکشنەکەم بزانە چی لێ چی لێ نایە چونکە لە چاپتەری سێ ئەویش دووبارە ریاکشنەکە دووبارەکەینەوە شەرح حەکەین بۆچی وای لێت بەڵام ئێستا مەسەلەن تێ بگە کە ئەبێ بە H3O با بڵێن Cl مەسەلەن ئەنانەکە
باشە
بگنێ باش سێکشن ڕڤیو ماماوە پرسیارەکان سێکشن ڕڤیو بزانین ئەوەی زەڕور بێ بۆتان شەرحەکەم ئەمە دەستی ئەمڕۆمە تەواو بێت. So section of question 1. It says write the equation for the solution of strontium nitrate in water. How many moles of strontium ions and nitrate ions are produced by dissolving 0.5 mole of strontium nitrate? So this is how you are going to do it. Strontium nitrate, we have the compound Na2. It dissolves becomes strontium and 2 nitrates. So if this is 0.5, it says it's 0.5. What is how many moles of strontium and nitrate ions? So each one of them individual, and we can also find the total. So this is also 0.5. Why? Because the coefficient is 1, coefficient is 1. What about this one? 2 times 0.5, it is 1. So the total is 1.5 mole ions. Okay. Now, question 2 is for yourself. Please try to solve question 2. Even if you have the answer, you also have the answer key, but just try to learn how to write the compounds, just the formula. That's why I want you to learn how to write the formula. It says, question 3, what determines whether a molecular compound will be ionized in a polar solvent? Just check the idea, ionized. What decides if it's ionized or not? We said ionization depends on 2 things. See, the attraction of polar salt water molecules is strong enough to overcome covalent compound being broken, so the molecule will break. So the easier way to say this, instead of this one, the easier way is depends on, or let's say depends on A, bond strength, B, attraction, between solute and solvent. هتدوشت bond strength of solute طبعا. چی دیارەکە کە چی واکات کە شتێک ئاینایزە بەیاننا bond strengthەکەی چۆنە؟ لە هەمان کاتیشە ئەتراکشنی بینی سۆڵت و سۆڵڤنتەکە چۆنە؟ ئەگەر bond strengthەکەی زەعیف بێ کەواتە ئەتراکشنەکەش زۆر بێ ئەتوانێت بیشکێنێت و لێکیانجا کاتەوە. وڵا بڵێمەوەی سەر بۆی سەر. پرسیاری چوارم شەرحەکەی ڕێک مەزبوطە وتوێتی HCl بۆچی strong و بۆچی HF. Why HF is weak? Because HCl ionized completely, 100% ionization, HF ionized partially. HF ionized partially. Question 5. For each of the following pairs, tell which solution contains the larger total concentration of iron. هذا كامل معنى iron زۆرتیایە. کوڕن ئەم پرسیارە لە زۆر شوێنێتی شار ڕەنگە بێتەوە پێشتان یعنی تێگەیشتنەکەی بەس لۆجیکەکەی تێبگا زۆر ئاسانە. نەیوتوە مثلا چه ئایۆنێک چوون کە فڵانە ئایۆنی زۆرتر نه وتوتی کامیان ئایۆن زۆرتر دروست دەکات باشە طبعا وەڵامەکە بەڕێوە چییە ئێستا مەسەڵەن ئەسەرەکە شیاوە دەزاوە سەرکارێکی گەنج شەرح کردووە ئەڵێ کام لەمانە contains the larger total content طبعا الدرجة یەکەم کێیە سیە باشە بۆ لەبەرەوەی طبعا concentration HCl زۆرە لێرە concentration HCl توش زۆرە کەواتە ئەم دوانە ئایۆن زۆر دروستەکەن ئەی بۆچی مەسەلەن یەکەم بۆ نابێ بر یەکەم ئەمەنە مۆڵار لە HCl و مۆڵاری HCl لێرە کەمە بەڵام بێجگەلەوە کالیسیوم کلۆڕایت کە دێنە بێت چەندێک ئایۆنیشە کاتە ناو سۆڵژنەکە 3 مۆڵ ئایۆنە کاتە سۆڵژنەکە کاتە کۆنسەنتریشنەکەی زۆرە بێ ژماری مۆڵەکانی زۆرە بێت کۆنسەنتریشنیشی زۆرە کەواتە سی دەرەچێت ئەی بی HCl و HF ئەسڵەن ئایۆن هە زۆر ناکاتە سۆڵژنەکەەوە ئەسڵەن چییە ویکە ئەلکترۆلایتە ئایۆنی هەر زۆر نییە ئایۆنەکە هەر زۆر کەمە کەواتە ئەڵێ وەڵامی سی زۆرترین ئایۆنێتیەکە بۆ هەم HClەکەش بە تەواتی ئایۆنایزەکە هەم کالیسیوم کلۆرایدەکەش سۆلیبڵە ئایۆنی کۆمپاوندێکی سۆلیبڵە بە تەواوەتی هەبێ بە ئایۆن هەم بێ بە ئایۆن و زۆریشە ئایۆنەکانی 3 مۆڵ ئایۆنیش دروستەکە ئێمە ئەوە بکەین کاتە بێت تۆ بیر لە چی بکەیتەوە هەڵێکم بیر لێ بکەی کە بزانی ئایۆنایز یان خۆت سۆلیبڵە بە تەواتی ئایۆنایزەکە یان نە ئەمە یەک دووەم چەندە مۆڵ دروست دەکات سێم کۆنسەنتریشنەکەشی چەندێک هەر سێ خاڵەکە بێت ئەستا لێرە ئەمە کەمە 0.05 بەڵام لێرە هەردووکیان 0.1 بەڵام ئەم دوانە بە کۆنسەنتریشن ئەنی یەکەن 0.1 ئەی چی گۆڕاوە HClەکەش ناوەکو یەکەن ئەم دوانە گۆڕاوە HF وی کە ئەم ئایۆنی کۆمپاوندە سۆلیبڵە لە هەمان کاتە ئەم چی تریشە لە بری ئەوەی 2 مۆڵ کە جیا بێت 2 مۆڵ دروستکە it will form 3 moles calcium chloride will form 3 moles that's why it will have a lot of ions چیشی زۆرترە بێ ئایۆنیشی زۆرە بێ بۆ منە کاتی کالیسیوم کلۆرایدەکە جیا بێتەوە بە کالیسیوم دایدن 2 کلۆراید 3 مۆڵ ئایۆن دروستە 3 بەش